Here's problem 3029. Two long parallel wires separated by 5 millimeters each carry a current of 60 amps. These two currents are oppositely directed. What is the magnitude of the magnetic field at a point that is between the two wires and 2 millimeters from one of the wires? Well, this is a lot nicer problem than the ones we've been working on. So we can actually put these two wires on the x-axis. And let's have one wire come out of the page towards you. So we'll call that I1, which is 60 amps. And then we have the other wire, I2, also 60 amps. And that actually is a current going in the opposite direction, so we'll have that go into the page like that. And we want to find what is the magnetic field at a point 2 millimeters from, we'll say, that wire at x equal to 3 here. So that's our point right there, P, that we wish to consider. Now if we use the right hand rule for the magnetic field going around I1, we would end up with a magnetic field going circularly around here counterclockwise, and in particular tangent at point P, that magnetic field would be going in the positive y direction. Let's call that B1, going up like this. And then if we were to consider a magnetic field going around, by the right hand rule, around I2, it actually would be going clockwise around I2 with a radius of 2 millimeters, like this, around this circle. And at point P, it also would be tangent on that circle, and it also would be going in the y direction. So that would be B2 going up as well. So these two magnetic fields are going to add in the same direction in the positive y direction as we've drawn it. So we just need to find the magnitude of these two fields. If we look at B1, for an infinitely long wire, that's going to be mu naught I1 over 2 pi R1. Mu naught is 4 pi times 10 to the minus 7. I1 is 60 amps, and this would be over 2 pi. We are 3 millimeters away, 3 times 10 to the minus 3. The 4 pi divided by 2 pi will leave us with a 2, and the 60 divided by 3 will leave us with a 20. So we'll have 40 times 10 to the minus 4, or 4 times 10 to the minus 3 Tesla, going in the up direction. For magnetic field 2, we have mu naught I2 over 2 pi R2, and that's equal to 4 pi times 10 to the minus 7 times 60 amps, over 2 pi, and we are only 2 millimeters away, 2 times 10 to the minus 3. The 4 pi divided by 2 pi will give us 2, and the 60 divided by 2 will give us 30. So this would be equal to 60 times 10 to the minus 4, and that would be 6 times 10 to the minus 3 Tesla, also in the same positive y direction. So our net magnetic field is going to be totally in the y direction, and it's going to be the sum of these two fields, B1 plus B2. So it's going to be equal to 4 times 10 to the minus 3 plus 6 times 10 to the minus 3, which will be 10 times 10 to the minus 3 Tesla, or 10 millitesla, or we could write it as 10 or 1.0 times 10 to the minus 2 Tesla. That is our net magnetic field, and as we've drawn it, it is indeed in the positive y direction, like this.